Alright, so we're back. So here's the second half of this deep learning on-ramp. So at this point, we're back to our coding, and we're not on the drag and drop interface like we'd had before. So they're giving us some code to start with. And they say, go do the same thing that they told you to do. Can it be that easy? Yeah, it's that easy. Just jump to the next one. And they want us to change the learning rate of our training options. Okay. So with that said, let me go ahead and reuse some of this code. And I'm going to go ahead and do our initial learning rate equal to 0.001. So we did the same thing we did before. We're just modifying that one parameter. Let's see if they liked it. They liked it. It's easy as that. So we're changing parameters associated with that one aspect of it. Go ahead and watch this video. I'll see you when you get back. We can do things in little batches and test and compare them to each other. We'll talk more about that when we get into the deep learning lecture. And we can use a GPU to enhance our ability to do what it is we're doing. Okay, so I've got a command line down here at the bottom, and they've given us transfer learning example. We see that we've gone through and how many iterations within that first epoch, how long it took for each one, the accuracy for those mini batches, and what the loss was on it. And then we see our learning rate is what we set it at, 0.001. So we did this up to this point. We did that right there in the previous task. Now they've set max epochs at 1 and the verbose frequency to 2. They went through, did everything they had to do, and it's all run out for us. Let's jump over to the next section. We're about 3/4 of the way through this, and up to this point, we've seen the pipeline. We've gone in and we've moved things around in it, modified an existing model, and how do we know if it's doing what it's supposed to be doing? Now, that's something that we would dig deep into if this was a deep learning course. Get an understanding of the metrics to determine how accurate is this model in a given context. So it's not one metric does everything. Here's the perfect metric for everything. That's just not the case. Okay. So we've got to evaluate the network after it's done doing its training. All right. Now, what have we done up to this point when we wanted to kind of visualize things? We created a histogram. We plot it. So let's go do that, and we've done that already. Say I want to plot info about training loss. I want to see training loss, and I want to go ahead ahead plot how it all looks. So as I go through my iterations, I see my loss is decreasing. So it's getting better. One of the things we'll look at, and if we were digging deep into deep learning, is why did it get better? Is loss actually decreasing, or is it not? What's actually going on? And those are the kind of things we dig into in, like I said, the deep learning courses. With this, I see that I'm getting better. I can assume I'm getting better. And what they're saying they want us to do is to go do some predictions on this. So we've got a data store, brought it in, we've got folder names, and we did our train test split. 99%. We went through and we resized, so we did all this pre-processing, get it all ready, and after we've got it all pre-processed, what do we got to do? Well, at this point, let's take what we've got, and we're going to say flower preds. Right there is what they want us to call it. That's going to equal our classification of FlowerNet, and I want to use my resized test images. Let's go ahead and run that and give us our predictions. Daisies, dandelions, whatever it may be. So we got through that part of it, and we can go play here if we want to. Let's jump on further ahead and let's look at the performance of what's taken place. So now we're looking on the test side. Before we were on the training side, we're looking at the test side. And I want to know how accurate this thing is. So on the test, we give it known images and see if it got it right. Okay. So they said we're going to use this flower actual, and that's going to equal, we've got test images is what we're dealing with for this. And we want the labels. Give me the labels for what we've got in our test set. All right, we got that. And at this point, we're going to do a logical comparison. We're going to carry on with what we've done, and they say let's get our num correct, and that's going to equal our NNZ flower preds that are equivalent to flower actual. So we compare the predicted to the actual, and that'll give us how many we got right. So we predicted 91 or 31 of them correctly. All right. So from there, we got a couple more. What's the fraction that we come up with? What percentage? That matters. So on this, we're going to say the fraction correct equals num correct divided by L flower preds. All right. We'll go ahead. So we're good there. So we're at 91.18% correct. Is that good accuracy? Maybe. We just don't know at this point. Now, that's how many we got right. Misdiagnosis or misclassification, that can be a big deal. Let's go look at that kind of thing. So they're giving us a function. I'm calling it a confusion chart. Reminds me of confusion matrix. And we're saying flower actual and flower predictions. Let's go ahead and run that. It's always better when we create some kind of graphic to represent what it is that we have in numbers. We call it a confusion chart, confusion matrix. What we predicted, what they should have been. Now we can see which ones were misclassified. Dandelions was predicted as a daisy. Tulips classified as sunflowers. Roses classified as tulips. So we know where the issues exist. That helps us get an understanding of how bad things are or how good things are. So let's pop on through it. Watch the video, see when you get back. So we've got our network. We create our train test split. We modify different things relative to our training. We do the training. Use that trained network to classify what we have. And then we go through and we evaluate what it was we've done. And now we've gotten to the end of our loop. If we like it, we proceed. If we don't like it, or we want to try other things, we circle back around and have at it again. So let's jump into the next module. So you'll see this in one of your assignments. It's roundworms. And one of the things that we'll do is determine roundworm vitality. So roundworms, the name says it all. They have roundness to them. So none of them are straight. They're all round. But if they're dead, they're not round. And we'll see that here. There's the straight ones. So these are not happy. These are dead. These are alive. Okay? And then we've got to go through and see which ones actually are alive and which ones are dead. So we want software to go count, predict which ones. So let's say somebody's gone through and they've manually detected which is which. Now we'll have the software go do the same thing. So with that, it says congratulations. Apparently it thinks we've gotten all the way through it. And we should be able to go here, fill this out. I submit it. It says, now I'm done. And now I go back to Deep Learning Resources. And here, let's say my courses. Here's my on-ramp that I just finished. Share my certificate progress. Let's jump in there and I can copy it. My course certificate, which is different than progress report. I don't need the progress report. I just need this course certificate. Copy that link or view the PDF and then download the PDF, and now I have the PDF. Okay? So with that said, we're done with this one, and I will see you in our next session.